Hey guys, all right, so if you can take out your packet that you got yesterday in class, it's called Graphs of Polynomial Functions. I know last night you watched an ed puzzle introducing some of these questions, so we're just gonna continue on with them in class today. All right, so if you recall, we know that the roots or the zeros or the solutions, right? These three words mean the same thing. These are the x values at which the graph crosses or touches the x-axis. So if you look at this graph, right, the roots, the zeros, or the solutions would be at x equals -2, x equals 0, and x equals 3. Okay, so you recall that from last night's ed puzzle. So on this page, we're going to take a look at the rest of the examples on this page, actually. Okay, so number 2, what are the roots of the polynomial function graph below? So you may want to hit pause and see if you can come up with the answer for these on your own before I go over them, just so you can see, where you're at. All right, so again, the roots are where the graph crosses or touches the x-axis. So we see we have one here at -4, here at +2, and another one here at +5. So you can either just list your answers out as x equals, each one of these, or if you don't really want to write x equals, what you could do is you can put these three values in curly brackets. Okay, curly brackets look like this. And you just list them in ascending order, so from least to greatest. So -4, then you put a comma, and then 2, and another comma, and 5, and then you just close up the curly brackets. Okay, so either one of these two options is how you can write your answers. Okay, so now number 3. What are the zeros of this polynomial function? Now this one's a little different because they don't give us a graph. So what we're going to want to do is we're going to want to go to y equals in our calculator, right? F of x just means your function in terms of x. This is another way of saying y equals. When you see f of x, it means y equals. So go to y equals in your calculator, and you can plug in x to the third minus 19x minus 30. Okay, so now when you hit graph, actually I hit graph and my window was kind of messed up. So if that happens, a nice, an easy way to get a nice window that really shows you a lot is to hit zoom. That's on the top, right in the middle, zoom 6. Okay, you're going to a standard window. Now, when you do, what you'll notice is you have a graph that looks like this. Okay, so, this is not a multiple choice question, so you really should show some sort of work. So I'm going to just sketch a little picture of this. And a sketch does not have to be great. The sketch, you're just really showing where it crosses through the x-axis and basically the general direction of your graph. Okay, so I could see here that I have zeros at -3, -2, and +5. Okay, so -3, -2, and +5. And we could see that our graph goes up, comes back down, and then comes back up again. Okay, so at this point, I'm just going to label this f of x. I could write out my zeros as -3. I'm going to put them in curly brackets. -2, and +5. Okay, so there's my answer. One other thing I want to say, if you go to your table of values, if you hit second graph, okay, I actually had to take 2 pictures there because I couldn't get them all into one, but what you'll notice is that -3, the y value is 0, at -2, the y value is 0, and at +5, the y value is 0. That's why these are my zeros. So if you prefer to just go to the table of values, you can find your zeros like that also. Okay, so number 4, how many negative solutions to this equation exist? All right, again, they don't give us a graph, so I'm just going to go to y equals in my calculator, and I'm going to plug in 2x to the third minus 4x squared plus 3x minus 1. So you guys can do that as well and just see what the graph looks like. All right, so the graph actually looks something... I'm kind of zooming in here. I'm not showing a lot of the graph, but it looks something kind of like that, right? So they want to know how many negative solutions. Now, a solution is where the graph crosses or touches the x-axis. Well, here's a positive solution, but I don't see any negative solutions. There are no negative solutions. So the answer to this would be none, right? 0. There are 0 negative solutions. Okay, if you flip to the next page in the packet, number 5 was done for you in the ed puzzle, so I'm going to just skip right over that. So we're going to go to number 6. Now, this one says, which of the following is not, let me underline that, a factor of the polynomial? Now, a lot of you guys might say, all right, well, let me try to factor this. If I have 4 terms and tried to factor this by grouping, okay, here I would pull out an x squared, which leaves me with x minus 10. And then here, I mean, really the only thing I could pull out is a positive 1, which does not leave me with x minus 10. It leaves me with 13x plus 24. So unfortunately, we can't really factor this by hand. So that's going to lead us to a dead end. But what we can do is we can plug this into our calculator during, under y equals, and let's look at the graph. Okay, so you guys can do that. You can go to y equals and you can plug that in. And while you do that, I'm going to sketch on the paper what I see. Okay, so I see a graph that goes through, and if you're not sure, remember, you could hit second graph. You can go to the table of values and look at where y is equal to 0. When x is negative 1, y is 0. Okay, I'm looking at the table of values. When x is positive 3, y is 0. And when x is positive 8, y is 0. But even if you go back to the graph, okay, hit just graph or zoom 6, you'll see that the graph does go through the x-axis at negative 1, positive 3, and positive 8. Okay, and this is what our graph looks like. So now, if we have a 0 at x equals negative 1, doesn't its factor have the opposite sign? Wouldn't the factor be x plus 1? Okay, and if we have a 0 at x equals positive 3, wouldn't the factor have the opposite sign? It would be x minus 3. And same thing here. If we have a 0 at x equals 8, the factor would be x minus 8. So if we go up here and look at which factor we don't have right there, it's going to be this one right here, x plus 6. Okay, number 7. Which of the following functions has a factor of x plus 2? Well, I'm going to do this one, kind of the same way I did the last one. I'm going to graph these one at a time. And if it has a factor at x plus 2, doesn't that mean that the graph should have a 0 at x equals negative 2? Okay, so hit pause and graph these in your calculator one by one and see which one touches or crosses through the x-axis at x equals negative 2. All right, so it looks like the fourth one, right? The fourth one? Okay, this is what choice 4 looks like. Okay, you can see it crosses through the x-axis right here at x equals negative 2. So that's where we have a 0. If you want to draw a little sketch on your paper just so that when you go to study later on, you have it in your notes, you could just sketch a little picture of what this looks like. It looks something like that. It's a pretty bad sketch, but choice 4 would be our answer. Okay, because remember, the factor has the opposite sign of the 0. All right, so if we take a look at number 8 on the next page, we just want to know in letter A, what are the zeros? So the zeros are right here at negative 1, positive 2, and positive 3. So I'm gonna use curly brackets again. That way I don't have to keep writing x equals. So negative 1, positive 2, and positive 3. Okay, because the zeros are where the graph touches the x-axis. Okay, so what are the factors? Well, the factors would have to have the opposite signs, right? So if we have a 0 at x minus 1, its factor would be x plus 1. If we have a 0 at x equals positive 2, the factor would be x minus 2. And if we have a 0 at x equals positive 3, its factor would be x minus 3. Okay, so in letter C, let me just move this over a little. Oh, okay. Given that the leading coefficient equals 1, write an equation for f of x. Okay, so all we really have to do is we just have to write f of x equals, the leading coefficient is 1. So basically, you're going to put a 1 after the equal sign. And because it's a 1, you technically don't even need it. And then it's really just going to be 1 times each of these factors. So 1 times, I thought I had the pen on, x plus 1 times x minus 2 times x minus 3. Okay, this right here is the equation in factored form. Okay, these are its factors. Now, if you notice here, this equation has 3 directions. It goes up, down, and back up. Okay, this is called a cubic function. So a cubic function basically is when you have y equals x to the third power. And if you notice from our equation here, we have x. I mean, there's numbers involved in this, but we have an x times another x times another x, which would be x to the third power, okay? Although we have numbers involved too, but when we have three x's being multiplied together, that's x to the third power. So we call that a cubic function. So when it says what is the degree, you can either count the number of directions, right? 1, 2, 3, up, down, up. Or you could say x times x times x is x cubed. So the degree is 3. All the degree means is basically the biggest exponent of the function. So the degree is the biggest exponent. Okay, and again, when you have a third degree function, we call that a cubic function. So if we take a look, I'm just looking down here. If we take a look at the next one, that's also a cubic, right? It has 1, 2, 3 directions. So it's going up, down, up. So down here, I'm going to actually do letter D first, since we were just talking about what is the degree. It is a third degree function. Okay, now let's do the rest of it. I'm going to go back to letter A. What are the zeros? So the zeros are where the graph crosses or touches the x-axis. So we have a 0 at -4, -1, and +2. So -4, -1, and +2. So if we want to know the factors, right, in part B, the factors just have the opposite sign. So if we have a 0 at x equals -4, the factor would be at x plus 4. Right, if we have a 0 at x equals -1, the factor has the opposite sign. It would be x plus 1. And if we have a 0 at x equals +2, the factor is x minus 2. Okay, and then part C, so this time we're given that the leading coefficient is 1/4. Write an equation of f of x. So it would just be f of x equals, and we put the leading coefficient, which is 1/4, followed by its factors, which is x plus 4 times x plus 1, just got to give myself a little more room, times x minus 2. And again, just to check the answer to part D, we have an x times another x, right? If we multiplied all this out, granted we'd have numbers involved, we'd have x squared terms, x terms, a number at the end, but x times x times x is x cubed, right? X to the third degree, and that's why it's a third degree function. And again, you could tell by looking, because it has 3 directions. It goes up, down, up. 1, 2, 3. Okay, so on the next page, we actually already did number 10 on the Ed puzzle, so I'm going to skip over that. But I'm going to take a look at number 11. So with number 11, it says, in part A, what are the zeros? Same thing as we did on the last few questions. The zeros are at x equals -3, x equals +2, and x equals +5. Okay, so x equals, I'll do curly brackets again, -3, +2, and +5. So we know that the factors would have the opposite sign. So the factors would be x plus 3, x minus 2, and x minus 5. Now, here's the thing. I'm going to actually skip down to letter D for a minute. It says, what is the degree of f of x? Now, if you think about what we talked about on the last one, if we look at how many directions it has, it's going down, up, down, up. So that's 1, 2, 3, 4. So for the degree of the function, I'm going to put it's a 4th degree function. Okay, it has 4 directions. But x times x times x is x to the 3rd, not x to the 4th. So if you remember from last night's Ed puzzle, if the graph bounces off the x-axis, like see right here, it's bouncing off the x-axis, we say that it's tangent to the x-axis. We say it has something called multiplicity. Okay, and what that means is there's a multiple root at that point. So here, let's write out these notes here, okay? So at x equals 2, Okay, there is multiplicity. Sorry, my pen was not working. There is multiplicity of 2. What that means is there's like a repeated root, okay? X equals 2. If you were to, take this equation of the function and solve it, you would wind up getting x equals 2 and x equals 2. You would get 2 roots of x equals 2, okay? So to compensate for that, what we do is we put a square on the factor that corresponds with that root. Okay, so let me explain this again. When the graph bounces off the x-axis, okay, see how I'm just going to scroll up. See how in the one above it was bouncing off at x equals 1? Here, it's bouncing off the x-axis at x equals 2. We say it's tangent to the x-axis. When that happens, it means we have a repeated root. We have multiple roots, okay? Here, there are 2 of the same roots, all right? So what we do is we put a square on the factor that corresponds with that 0. So now if you think about it, we have an x. This one gives us 2 x's, right? When something's squared, it means there's 2 of them. And we have another x. So x times x times x times x gives us x to the 4th. And that's why the degree is 4. Okay, and then letter C. Basically, they just want us to write it in equation form. So f of x equals, they tell us that the leading coefficient is 1. And it's up to you. You can just write the factors in the order they're in. A lot of times you put your square first, although, I wouldn't mark off if you did. But if you want to just write the x minus 2 squared and then bring down the x plus 3 and the x minus 5, okay, I'm okay with that. If you want to leave these in the same order that was in, that's okay as well. Okay, on the next page, number 12. Given that the leading coefficient equals 2, write an equation for the function below. Okay, so let's first, in order to write the equation, we kind of need to know the factors of this. So in order to know the factors, we have to look at the zeros. So here we have a 0 at x equals negative 2. We have one at x equals 0. And we have one at x equals positive 2. Okay, so the factor that would correspond with the 0 of x equals negative 2 would be x plus 2. I'm just going to put it down here. The factor that would correspond with x equals 0 would really just be x minus 0, right? And then the 0 that corresponds with the, the factor that corresponds with the 0 of x equals 2 would be x minus 2. All right, now it says that the leading, actually they don't even tell us whether to call it f of x or what. I'm going to call it f of x, and they tell us that the leading coefficient is 2. Now, let's also see if we have to put any squares on any of these, okay? Let's see if it's bouncing off the x-axis anywhere. Nope, here it's going right through. At 0, it's going right through, and at 2, it's going right through. So it's not bouncing, it's not tangent to the x-axis. And it makes sense because if it goes up, down, up, right, it has 1, 2, 3 directions. That's why we have 1, 2, 3 x's. Now I'm going to make this look a little prettier because let's think about it. See this x minus 0? Isn't anything minus 0 just itself? Like, isn't x minus 0 really just x? And when we reorganize this, wouldn't we put the 2 and then the x, like 2x in front of these other 2 factors? So I'm going to rewrite this as f of x equals 2, and then again, I'm taking this x and bringing it, I'm taking this x and bringing it right next to the 2, and, change colors. And then I'm going to bring down my x plus 2 and my x minus 2. Now, I just want to point out, this is the equation in what we call factored form, okay? All the factors are separate from each other. If they wanted it in standard form, you would have to multiply this out. You would double distribute, and then you would distribute the 2x and combine all your like terms, and you would write this in standard form. Sometimes less is more, right? Less steps, less room for error. Okay, so let's just try the one below it as well. So given that the leading coefficient equals -1, write an equation for the function below. All right, so I don't know if you guys have been like pausing it and trying to do these on your own, but if you haven't, definitely try it for this one, okay? Try to write this equation on your own, and then you could hit play and see how you did. Okay, so we have zeros. I'm just going to write these out. At x equals -3, x equals -1, and x equals 2. All right, so then the factors would be x plus 3, x plus 1, and x minus 2. Okay, all I'm doing is just taking these signs and reversing them. And they tell us that the leading coefficient is -1, so I'm going to put a -1 in front of this. And remember, if they want us to write an equation of a function, we need to put it in function form. We need f of x equals, and this is our answer. And you could always go to y equals in your calculator and graph these and just make sure that, you know, this graph on the paper looks like the graph in your calculator. Okay, so now we have some multiple choice questions. So if you could just try out the questions on this page on your own, and then when you're done, hit play and see how you did. Okay, this first one I think is pretty straightforward. You could see that we have zeros at x equals -3, x equals +2, and x equals +4. Okay, so basically we're just going to reverse the signs to find the factor. So the factor that corresponds with this would be x plus 3. The factor that corresponds with this would be x minus 2, and the factor that corresponds with this would be x minus 4. So this one's choice 1. All right, let's take a look at the next one. All right, so we see that we have zeros at x equals -3 and x equals +2. Okay, so the factors that correspond would be x plus 3 and x minus 2, right? Again, we just reverse the signs. So it cannot be choice 1 or choice 3. So I'm going to just cross those off to get those out of there. So basically we're deciding between choice 2 and choice 4. Now, I don't know who remembers this, but you could do one of two things. I mean, you could graph these in your calculator and see which one looks like this. Or, here's the deal. I don't know if you remember this, but when you have a parabola, right? If you have a parabola that opens up, that's always going to be f of x equals positive x squared. Okay, if you have a parabola that opens down, that's going to be f of x equals negative x squared. Okay, I always remember it's like a happy face, that's why it's positive, and it's a sad face, that's why it's negative. So since this one's opening down, it's a sad face, it's negative. So that's going to match up with choice 4. All right, and then number 16. So we have zeros at, I'm just going to write them out here. X equals -4. We have one here at x equals -2. And we have one here at x equals +1. So our factors are going to be x plus 4, just reversing the signs, x plus 2, and x minus 1. Okay, now if we look at these answer choices, right? All right, it looks like, see this x plus 2? We could see choice 1 has an x plus 2, and choice 3 has an x plus 2. So it can't be choice 2 or choice 4 because we don't even have an x minus 2 anywhere. So I'm going to cross off choice 2 and choice 4. So we're just deciding between choice 1 and choice 3. All right, well, let's think about this. I'm going to take these and I'm going to reorganize these. So I'm going to put the x plus 2 first, like it is in these two answer choices. And then why don't we take the x plus 4 and the x minus 1 and double distribute them to see which one of these trinomials we get. All right, so x times x is x squared. X times -1 is -1x. 4 times x is +4x. And 4 times -1 is -4. Okay, I'm going to bring down the x plus 2. Now, when I combine my like terms, I would get x squared. And then -x plus 4x would be +3x. And then -4. And I'll bring down the x plus 2. So let's see which one that matches up with. That matches up with, right here, choice 1. So choice 1 is the answer. I mean, the other way you could do it, which is super easy, you could just plug these in your calculator one by one, like just graph them in your calculator one by one and see which one looks like this graph.